Okay, this is tutoring for intermediate algebra at Raritan Valley Community College. This is test 3 review, doing some example problems. So to start, we're going to begin with functions. And first we're going to start with this guy right here, f of x equals 5 minus 3x squared, and evaluate it when x equals -3 and x equals 1. So when x equals -3, okay, that's going to be f of -3 f of -3 equals 5 minus 3, parentheses, you always want to put in parentheses, -3 all squared. Well, then I'm going to continue to evaluate it. It's going to be 5 minus 3, -3 squared, that gives me 9. And then this is going to equal 5 take away 27, which is just equal to -22. So that means when x equals -3, y is -22. So now, if I do another one with f of x where x is equal to 1, well, again, same thing, so now I'm applying, except now I'm plugging in 1 for x. So f of 1 equals 5 minus 3 times 1 all squared. Well, 5 minus, well, let's see, 1 squared is 1, times -3 is just -3, equals 2. So that means when x is 1, y is 2, so f of 1 equals 2. And then now we're going to get into, okay, finding domain and range of a function based off the graph. So I've looked at the graph right here. What is a domain? Well, this is a parabola, and if you notice, you have arrows here. They go on forever in this direction and that direction. So what that means is they go down forever and ever and ever and expand out, and down, 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 and expand out. So a domain is just x, because x is always the domain. X is all real numbers. Now, what about the range? Well, the range, well, if you notice in the y-axis, the function stops here. What point is that? Well, let's see. I start at 0. I go 1, 2, 3, 4. So the range is all real numbers up to 4. So the way you can say that is just say y is less than or equal to 4. Now, if I go to a problem like this and they want me to find values of functions based off the graph, well, f of 0. Well, f is 0. That means x is 0. Well, so where x is 0, where's the graph? Bam, right there at 1. So f of 0 is 1. Similarly, what about f of -3? Well, that means x is -3. I look at the graph. I start here, -1, -2, -3. Where does the graph fit? I have to go up 1, 2, 3, 4. So that means f of -3 is equal to 4. And if we look at section 8.2, identifying linear functions, well, as I mentioned in the content video, how do you know if something's linear or not? What does linear mean? It's a line. So if I look at this function here, this is not a line. It's curved. So this is not linear. If I look at this, I have a straight line going like that. Well, that means it is linear. Now, sometimes they might give you graphs, or excuse me, functions, and you have to tell whether by the function whether or not it's linear. If I look at this guy here, f of x equals -3x plus 7, well, if you notice, I have a first degree term here, and it's also in the form of f of x equals mx plus b, where m is the slope of the line, b is your y-intercept. So that means this is linear. For this function, f of x equals 3 over x, well, yes, this is a first degree term, but it's in the denominator. It's not in this form. So since x is in the denominator, that means it is not linear. Or you could just say non-linear, same thing. So now, if we go to compound inequalities, where I have this, 2x plus 7 less than 5 and negative 2x less than or equal to 6. Okay, so if I start here, start with this guy, I subtract 7 from both sides, I get 2x is less than negative 2, divide by 2, divide by 2, x is less than negative 1. And then I look at this guy. Negative 2x is greater than or equal to 6. Divided by negative 2, divided by negative 2. X is less than or equal to negative 3. Now, I have to plot these on a number line. So if I draw a number line here, okay, I have negative 3, negative 2, negative 1, 0, 1, and so on. So, okay, at first glance, oh yeah, I could just say negative 1 this way. And open circle, because this is less than, and then less than or equal to negative 3, darkened in, going like that. But the question is, we can't just assume that, because how do we know if that's true? Well, first off, since it's an and statement, that means that whatever x values, the x values have to hold true for both of these. So it can't just be one. So for instance, if I look at, say I pick a point inside of here, between these two. So say I pick negative 2 for x. If I plug in negative 2 in for x here, I get 2 times negative 2, which is negative 4, plus 7 is 3. 3 is less than 5. That works. So now if I take negative 2 again for x and plug it into here, that's going to give me negative 2 times negative 2 is 4, but 4 is not greater than or equal to 6. So it can't be anything in here. And what about x is less than or equal to negative 3? Well, if I plug in negative 3, or actually, let's do negative 4. If I plug in negative 4 here, 2 times negative 4 is negative 8, plus 7 is negative 1, which is less than 5. And if I plug negative 4 into here, negative 2 times negative 4 is 8, which is greater than 6. So that means the solution is everything beyond here. So x is going to be less than or equal to negative 3. Now here I have an or statement. Same thing as the other one, except now since it's or, it only has to satisfy one equation or the other one. Meaning that when you pick an x value, it only has to satisfy one of the equations, not both. So I have 5x minus 1 less than or equal to 3. I add 1 to both sides. 5x is less than or equal to 4. Divided by 5 to both sides. X is less than or equal to 4/5. Here I have 1 minus x less than negative 1. Minus 1 from both sides. And I get negative x is less than negative 2. Divided by negative 1, and be careful because since I'm dividing by a negative, the sign has to flip, so it's x is greater than 2. So if I were to graph this on a line where I have 2 here, say this is 1, this is 0, and I can say 4/5 is there. So less than or equal to goes that way, and x greater than 2 goes this way. Now again, if I pick 0, okay, and plug it into this equation, negative 1 is less than 3. Great, it works. So that's it. As long as it works for one, we're fine because it's an or statement. If it was and, it has to satisfy both. Say I pick 3. Plug in 3 into this equation. 5 times 3 is 15 minus 1 is 14, but it's not less than 3. Oh, it doesn't work. But let's test the other one. Plug in 3 for this inequality. 1 minus 3 is negative 2, which is less than negative 1. So that is definitely our solution for this problem. Now we have absolute value inequalities. So with something like this, I have to set up 2 equations, 12x minus 24 equals 24, and 12x minus 24 equals negative 24. So if I add 24 to both sides, I get 12x is equal to 48. Whoops, sorry about that. Divide by 12 to both sides. X is equal to 4. This guy at 24 to both sides. 12x equals 0, divided by 12. X equals 0. So those are the solutions for these two. X equals 4 and x equals 0. So now, I'm going to erase this so I have some room. And we're going to look at this guy, the inequality. So this word, an absolute value inequality. Now this is a little bit trickier because, yeah, you have the plus or minus, but you have to be careful because first off, okay, I'm going to have 5 minus 3x is greater than 3. But then the other one, I'm going to have 5 minus 3x is less than negative 3. So I subtract 5 from both sides. Negative 3x is greater than negative 2. Divide by negative 3 to both sides. X is less than 2/3. Here, I do the same thing again. I subtract 5. And negative 3 is less than negative 8. Divide by negative 3. Divide by negative 3. X is greater than 8/3. So now, you have to figure out what is the solution set. So you have to think about, okay, what if I put this on a number line and 2/3, yeah, this would be 0, this would be 1. We could say this guy is 2/3 right here. 8/3, that's just 2 and 2/3, so we can say that's right about here. So we got an open circle here, open circle here. So yeah, okay, this way and this way. The question is, does that hold? Well, let's see. If I pick a value less than 2/3, such as 0, plug in 0 here, you get 5. Absolute value of 5 is 5. It's greater than 3. If I plug a value here for 8/3, such as, or a value greater than 8/3, such as 3, you do negative 3 times 3 is negative 9. 5 minus 9 is negative 4. Absolute value of negative 4 is just 4. So it does work. So that means it could be this or that. Oh, my bad. Okay. So that will do it for this. This is part 1. And I shall see you in the second part next time. Take care, everyone.